Hello and welcome in to the content video for lesson 4 for Precalculus 2. In this video, we're going to be looking at our inverse trig functions. So we knew things like, okay, what's cosine of pi over 6? That's root 3 over 2. But what if we want to go the other way? What if we want to say, okay, if my cosine value is root 3 over 2, what's the radian measure associated with that? Pi over 6. So to do that, though, and for you guys that are going to be going on to calculus, these inverse trig functions and the domain and range is critically important. So let's first look at the inverse sine function. So if I sketch out part of the sine curve, so remember this thing goes on, I guess it would help to share my video camera, right? Or my document camera. That could have been a lot of wasted time. All right, so there we go. So we're going to talk about the inverse sine function. My sine curve, remember it starts at 0, goes up to 1, comes back through pi, continues on, goes down to -1, and so forth. So for the sine function, in general, the domain is what? Negative infinity to positive infinity, and the range is -1 to 1. But the issue we run into is like, let's say that I said, well, where on the sine curve is sine equal to -1/2? Well, there's a lot of places, right? Because this thing goes to negative infinity to positive infinity. So there's a bunch of spots. So what we have to do then, when we're looking at the inverse sine function, is we have to restrict ourselves to this part of the curve. So basically where the domain goes from -pi/2 to pi/2, in the range is -1 to 1. That way, everybody's talking about this same part of the curve where the answer is only going to show up once. If you remember back to your pre-calculus 1 days, if we have an inverse function, what is the relationship between the domain and range on a base function like sine and its inverse function like sine inverse? And the way we write this is sine with a little -1. Remember when we had f inverse, if we were doing functions, it was f to the -1 power. Same thing here. Sine inverse, sine to the -1 power. Well, what was the relationship? They just switched, right? So whatever the range was in the base function is now the domain for the inverse function. And what was ever the domain is now the range, -pi/2 to pi/2 with brackets, for the inverse function. So this, on a test, when it asks you, and it will ask you several times, what is the domain and range of the sine inverse function? That's what your answer should be. Domain is -1 to 1 with brackets. The range is -pi/2 to pi/2 with brackets. If I have the inverse cosine function, well, again, I have this issue with the graph goes from negative infinity to positive infinity. And so what we're going to restrict ourselves to on this one, whoops, move it into sight, sorry. So this is one period of cosine, but we're going to restrict ourselves now going from cosine, the domain is 0 to pi with brackets because it actually goes to pi. And the range is again -1 to 1. So for the cosine inverse function, the domain is now -1 to 1, and the range is 0 to pi. And again, from a testing standpoint, this is what you need to know. And then for inverse tangent, so here we are going to look at the regular period of tangent. So -pi/2 to pi/2 with the graph that looks like this. So for this function, the domain is going from -pi/2 to pi/2, but we have asymptotes there. So it's not included. So it gets parentheses. And the range is what? -infinity to +infinity are all real numbers. So therefore, tangent inverse, the domain is all real numbers, but the range is -pi/2 to pi/2 with parentheses. So that's what you need for the exam for tangent inverse. Now, why is the domain and range important for our inverse functions? Well, when we do an inverse sine problem, our answer has to end up falling in this range value. So for example, if I'm doing an inverse cosine problem, my answer can't be 3 pi because 3 pi is not between 0 and pi. Or my answer cannot be -pi/4 because -pi/4 is not between 0 and pi. And so a tricky way, or I don't know, maybe it's not tricky, maybe it's an easier way to do this. So when we are doing inverse problems, so for example, maybe I have something like sine inverse of 1/2. And so this is asking me, okay, instead of what is sine of some radian measure, instead I want to know what radian measure has the sine value equal to 1/2. But because of my restrictions, so sine is -pi/2 to pi/2. So if I was to draw a unit circle, where is -pi/2 to pi/2? It's right here on what? The right half of the circle. For a cosine, if I draw the unit circle and I'm going from 0 to pi, it's where on the unit circle? It's on the top half of the unit circle. And for tangent, if I draw the unit circle and my answer has to be between -pi/2 to pi/2, that's what? That again is the right side of the circle. So to do these problems like this, like if it says find the exact value of sine inverse of 1/2, I'm going to use the following question that I ask myself. every time I have a problem like this, I'm going to say where on the, and then blank half. And so this is either going to be the right half or the top half. If it's a sine or sine inverse or tangent inverse problem, it's going to be right half. If it's a cosine inverse problem, it'll be top half. So where on the blank half of the unit circle is, and then this is either sine, cosine, or tangent, depending which inverse function I have, equal to, and then this is the given value that I was given. Oops. So let me stop for a second while you get that written. This is the question we will use every single time. So this example I have here, sine inverse of 1/2. What this means as a question is where on the, and because it's sine, right half of the unit circle is sine, because I was given the sine inverse, equal to, and what value was I given? 1/2. So I go back to my trusty unit circle. I'm only going to look at the right half. So remember, let me zoom out a little bit so we can see the whole circle here. Remember that when we started talking about the unit circle, I said, okay, think of this like a sidewalk in a park. And you're walking around and you want to get to all these different points. Well, now that we're talking about inverse function, the left, so for sine inverse, think of this like there's a fence built on the y-axis. And so I cannot get past the fence up here, and I cannot get past the fence down here. So I'm just looking at the right half, and I want sine, which is the y value, is equal to 1/2. So if I look at that, it's what? It's right here, right? So sine is equal to 1/2 at pi over 6. Therefore, the answer to this original question, sine inverse of 1/2, is equal to pi over 6. But what if I have something like this? Sine inverse of negative 1/2. Okay, well, we're still going to use the same question where on the right half of the circle is sine equal to negative half. So I pull this up and I look at this and it's like, okay, right here. So sine is equal to negative half at what? 11 pi over 6. But what's the problem with me saying the answer is 11 pi over 6? Well, I can't get to 11 pi over 6 because I have this fence built down the y-axis. The only way to get to this point is to go what? Negative pi over 6. Because remember, my answer for sine has to be between negative pi over 2 and pi over 2. And 11 pi over 6 is not between these two values. So for this one, my answer must be negative pi over 6. If on a test you tell me the answer to this is 11 pi over 6, it's wrong. It cannot be. And so for sine inverse and tangent inverse, if your answer is in quadrant 4, your answer must be negative. So do not give me 11 pi over 6. Do not tell me 7 pi over 4. Do not tell me 5 pi over 3. It must be negative pi over 6 or negative pi over 4 or negative pi over 3. It has to be negative if you're down there in quadrant 4. Anything else means you tell me you don't know what you're doing. And George, go ahead and mark it wrong because I'm not sure what's going on here. So that's it. That is our inverse trig function to solve these problems. We're just going to use that question every single time. And that should lead us to the right answer. The only thing we have to be careful about is this guy here. If you're in quadrant 4, your answer has to be negative. So that's it for the content video. Come on back and we will look at a bunch of examples.